All right, I'd like to call to order this meeting of the Brew Robotics Club, July 31st. Great pleasure to have with us today Erin Rapacki with NVIDIA, talking about accelerating the next wave of AI robots. And so let's go ahead and get this meeting kicked off here. We always start off with industry news. Any industry news anybody'd like to report out there? Robot industry news. Don't everybody go at once.
OpenAI has just released another version of ChatGPT for Omni. I downloaded it this morning. I don't see any changes.
You say for Omni. How so Omni?
Omni is the one that can do picture uploading and various voices and sound effects, they're telling us.
Oh, so that's ChatGPT 4. Omni?
For Omni. There's no point. It's 4.0 Omni as far as I understand.
All right.
I queried the AI this morning and it didn't give me any version number.
All right. Any other robot news out there? There's a new movie coming out, and I just put a link in the chat there. Let me share my screen real quick. It's called The Wild Robot.
Camp, we're not getting any sound. Camp, no sound.
Yeah, sorry about that. I don't have the sound on, but we're not even, let's do this. So I've got the link in the chat there if you want to check that out. New movie coming out called Wild Robot. Any other robot news this evening?
Can you hear me?
Yes, we can hear you, Jeremy. Go ahead.
Yeah, I apologize. I'm driving, so I apologize for the background noise. I just wanted to quickly mention that Ross is discussing whether to drop support for Windows. Windows 10, of course, is going to be gone 2025, and the Windows 11 taking its place. And so there's actually a questionnaire that the Ross discussion group has put out for comments. So I certainly recommend if people are interested in that they provide their feedback for it. I think I sent it on the email.
I'll tell you, I tried to install Ross on Windows one time, and they lost me at chocolatey.
Yeah, right.
What else? We got any other industry news out there? Oh, I got one more. Elon Musk says his Tesla Optimus robot could drive the company to 25 million. That's trillion with a T. He thinks big, if nothing else. Valuation. I'll put a link in the chat here. It's a Forbes article. I think maybe you get 3 or 4 free ones before you have to subscribe, but there's the link there. What did he say? He said some interesting things. Let's see. What's the point of humanoid robots? Well suited for working within human environments, etc. It was talking something about the AI and generalization and stuff like that. So the robots being able to generalize concepts and so forth versus having to program for a million different situations. But there's the article in Forbes if you want to check it out. Any other robot news out there this evening? Okay, let's move right into club news now. Any club news out there? Somebody want to announce something or say something? So we have a lot of interesting groups going on in the club, I assume everybody's on the mailing list, the HPRC mailing list. That's where you get all the news and stuff. I'll put a link in the chat. But we have a ROS discussion group that meets on Tuesdays. We have a special ROS engineering group headed up by our own Mike Wimble. This is an exclusive group where you have to commit to an hour and a half presentation to be part of it. Serious builders. And then we have our Builders SIG on the penultimate Wednesdays, and of course this general meeting on the final, I guess we'll call it the ultimate Wednesday, where we actually have a presentation. Erin Rapacki with NVIDIA's here, and there's also a voice intelligence group, SIG, special interest group, VIG-SIG, that meets on Thursday evenings. Thomas, you want to say a word about the VIG-SIG?
Yeah, we're meeting to discuss the latest in AI, generative AI, especially as it relates to vision, voice, voice input, voice output, vision in, photos out even. And we're running classes at the same time. We're running the class on the OpenAI's API. So we're doing all that weekly, 7 o'clock on Thursdays, 7 p.m.
Mike Wimble, you want to say a word about the ROS Engineering Group?
Yeah, we meet about once a month. This is a group for people who are willing to give back to the community. To join the group, you have to commit to doing a 2.5 hour presentation sometime in the next year. And this is a deep dive. This is light on the show, heavy on the tell. People give a lot of details about what went into the robot, the hardware choices, engineering choices, how the software works, and so forth. The results of the meetings are available on the web, but to join the group, like I say, you have to commit that you will make such a presentation. We've had 3 so far, and
Nathan Lewis is going sometime this month or next month, right?
Yep, had some really good presentations so far. That's it.
That's the ROS Engineering Group. Contact Mike Wimble if you want to be part of that group. And we've got the Botnik coming up on September the 22nd. That'll feature a Robo Magellan event. I think Ralph Hips isn't in this evening. Yeah.
Yeah, I wanted to talk about
Out there in person, Dan.
looks like about 20.
All right, we got 27 online, so that's almost 50 folks. 50 robot enthusiasts. Okay, next. Any other club news out there? September is going to be the challenge month again, so everybody's building, right? It's a builders club. Our stock and trade is functioning robots, but works in progress are good for partial credit. Next segment, what I need help with. Anybody need help with anything specific? Or maybe he's had a breakthrough or something like that. All right, everybody's making progress.
I've had a mini breakthrough.
Go ahead, Mike Wimble.
So I've been rebuilding my robot. Raven is Nevermore, and we're on to Sigyn, or Sigyn is the new robot. It'll be circular and will indeed include an arm. I've already bought the 4-foot vertical elevator and part of the horizontal section of the gripper for the thing. But the last few days, I've also been trying to get Micro ROS to run on the Pico 2040W, in particular the one from Seed Studio. They had a sale on them a few weeks back for under $5 a piece. So I bought a handful of these things. And it's just enough of a different of a beast that it took a while to figure it all out. But I took a lot of the code from my Teensy custom Micro ROS board and got a big chunk of it running on the Pico W. It looks like it can probably go through the loop. You know, there's a setup and a loop like Arduino, and it looks like it can go through the loop over 100,000 times a second. And that should translate into just about that many messages per second coming out of Ross. So exciting days ahead.
Very exciting. What else I need help with, or breakthroughs or something like that? Shoot.
Yeah. This is Steve. You'll need to get near the phone. Sorry. All right. The mic's on the bottom, so any side of it will work.
All right. So I realized that I had some ideas that I can put together to accurately locate a robot's head and its hands within a room. And so I'm sure that a lot of people have worked on that in one way or another. So I think it's something I'm going to start a discussion on and hopefully try out some of those ideas pretty soon. So I've realized that something that I have been wanting to find as a component was the inside out tracking that a lot of the VR systems use. And so I looked for that a number of times. It's hard to find, but I realized that I can probably use off the shelf hardware to solve that problem. So now I'm curious about who else has worked on that and if they've made any progress. So the idea basically is within a room, being able to know exactly where a robot's head is and in what orientation it is. And also at least the two hands of a robot or two end effectors or whatever. So I think it's an interesting problem area.
Send an email to the list.
Yeah.
What else I need help with or breakthroughs? All right, moving along to show and tell. Who has a show and tell this evening? I do. Let me switch over to my screen here. So this is a map that I've created. The robot stopped here. You can see I've got a camera on there, and I'm going to help him out here with the keyboard and drive him out. Am I sharing my screen? Can you see that? Hello, is this thing on? Let me share my screen. I'm sorry. Boom. Crash. Bang.
We see your screen.
All right, here's the robot, and I shall navigate to the living room here. Nothing up my sleeve. That's a real robot. The breakthrough here, and I'm using Lino Robot as a model. That's the model. But I've made a little model of our mock turtlebot from the Lino Robot. The Lino Robot out of the box. It's URDF, Universal Robot Description Format, is a that's a little floor transition there. 10-inch square, 3-inch wheels. In the Ross discussion group earlier, we had modified it to be a 20-inch square base with 5-inch wheels. And now I've made the mock turtlebot URDF, which is a 14-inch cylinder. That's actually a chassis, a Roomba chassis URDF on the bottom. We've got the top tabletop. The tabletop is the end effector. The concept is a smart table, a tray table that can reliably get from one place to another. So we're building the mock bot 28 ways. We're building it with different bases, Create or Roomba or BotVac. You can use whatever LiDAR you want, LD, DL, YP, XV, and the cameras. We'll have a variety of cameras one can choose from. But the concept is to make the equivalent of the TurtleBot, which is if you buy a TurtleBot from ClearPath, the TurtleBot 4 is a $2,000 robot. Now it's $1,000 worth of parts retail, including the Oak D Pro and stuff like that. I've got a little bit of a barrier from that transition there. Let's see if you can break through. Yay! And here it comes into the lounge. So I really like the Create 3 base. It's awesome. It's all ROS 2. You boot it up, and it launches all these nodes or packages and exposes all these topics. And I pretty much just Velcroed a DL06 LiDAR on there. and ran Slam Toolbox and started driving it around, and you could create maps kind of right out of the box. So let's see here. Boom. Yep, that's it. Thank you very much. Any other show and tell? Thank you, Thomas. All right. Without any further ado, let's get on with our presentation here. I'd like to introduce Erin Rapacki. She's senior developer relations for NVIDIA Robotics. Erin has 15 years of experience in robotics, industrial automation, computer vision, and IoT. She's particularly known for a role in helping companies in robotics, computer vision, and machine learning adopt the latest tools from NVIDIA. So without any further ado, let's welcome Erin Rapacki.
Let me just make sure my audio share is working. What was the settings? Share sound. Okay, so that should work. So I'm actually going to be telling the story through a lot of videos. I find that's the best way to explain robot simulation is by having, see the videos and the screen grabs of what it's doing. So this talk is actually borrowed from an industrial talk I gave at Automate, which is a manufacturing show that happened a couple of months ago. Now, how many of you have been seeing various NVIDIA news on the topics of robotics, maybe even more so this year? Yeah, we've been giving it a big push. But one of the things I like to do in my talks is that news is not the A to Z story. And we might actually want the light turned down in order for the videos to show up. Yeah, I think that'll be best. I was actually hoping the sun would go down a little bit so you can see it on the screen. I think it's farther now. We're not getting the glare, so that's good. But one thing I kind of tell my marketing team about is what's the whole story? Why are we doing this? How does it all add up? Because our news, we tend to talk about a little sliver here or an update here or a new feature there. But really the story is about embodied AI or calling it physical AI. It's kind of going under a couple of different phrases right now. And this is particularly borrowed from self-driving cars, which I would argue is why Elon sees the opportunity to build Optimus the humanoid using Tesla's self-driving stack. The entire AV industry, the ones that are successful anyway, are training their perception systems using simulation, or at least a portion of it. And while those companies have been able to build their own sim, and that's core to their IP, a lot of smaller robotics companies are not going to build their own sim. And the reason why the self-driving car sims are effective in contributing to the autonomy is because they have a certain amount of fidelity to it. And when I say fidelity, I want to say looks real, feels real. Now, the interesting thing with self-driving cars is the car isn't touching anything. So other than traction under the wheels, the feels real is not actually required. Looks real, or at least you get decent perception pipelines, that's simulation in there. In order to understand and classify the objects in the city, that's important. So many people in the self-driving car industry were doing this work, 5 or so years ago, but other types of robot companies didn't really have access to it. And so this was kind of the generation of NVIDIA Isaac Sim. And I'm going to actually start the story with the factory digital twin on the reasons why you want to simulate that. So here we go.
The world's industries are accelerating digitalization with over $3.4 trillion being invested in the next 3 years. We at BMW strive to be leading edge in automotive digitalization. With NVIDIA Omniverse and AI, we set up new factories faster and produce more efficiently than ever. This results in significant savings for us. It all starts with planning, a complex process in which we need to connect many tools, datasets, and specialists around the world. Traditionally, we are limited since data is managed separately in a variety of systems and tools. Today, we've changed all that. we are developing custom Omniverse applications to connect our existing tools, know-how and teams all in a unified view. Omniverse is cloud native and cloud agnostic, enabling teams to collaborate across our virtual factories from everywhere. I'm about to join a virtual planning session for Debrecen in Hungary, our new EV factory opening in 2025. Let's jump in.
Milan is joining.
Hello everyone.
Hi Milan, great to see you. We're in the middle of an optimization loop for the body shop. Would you like to see?
Thanks, I'm highly interested. And I'd like to invite a friend.
Sure.
Hey Milan, good to see you.
Jensen, welcome to our virtual planning session.
It's great to be here. What are we looking at?
This is our global planning team who are working on a robot cell in Debrecen's digital twin. Matthias, tell us what's happening.
So we've just learned the production concept requires some changes. We are now reconfiguring the layout to add a new robot into the cell.
Okay, but if we add a new robot on the logistics side, we'll need to move our storage container.
All right, let's get this new robot in.
That's perfect. But let's double check. Can we run the cell? Excellent.
Milan, this is just incredible. Virtual factory integration is essential for every industry. I'm so proud to see what our teams did together. Congratulations.
We are working globally to optimize locally. After planning, operations is king. And we've already started. To celebrate the launch of our virtual plant, I'd like to invite you to open the first digital factory with me.
I'd be honored. Let's do it.
With NVIDIA creating Omniverse. How many people here have ever heard of Omniverse? Okay, so great. Omniverse is based off of USD and Universal Scene Description. And that was actually invented by Pixar. So Omniverse is kind of the graphics environment, almost a unifying environment for NVIDIA Drive Sim, for these different factory digital twins. What you just witnessed there is a very practical application for a factory, is that in that scenario, they had a work cell, and they realized in order for the robots to operate the task at the tact time that they want, they need to add a fourth robot. And they had to think about space constraints, and they had to think about the motion planning or the work envelopes of those robots. So modeling everything in 3D already has a lot of practical applications with factory layouts. But then, moving towards the goal of what if the robot can program itself because it understands everything in the 3D environment. Well, and ideally right now, industrial robots take a lot of effort to program for a lot of good reasons. But there's this ideal scenario of what if they took almost no time to get going, because you already have the 3D model of everything anyway. Why can't it figure out its own path plan? It has the 3D model of the object. Why can't it figure itself out how to pick it up? I mean, when you have everything in 3D, why do we need to copy everything over and do everything from scratch? Do it in the simulated environment. That's the ideal scenario. So many people know NVIDIA has been around a while. If you're not familiar with the history, Jensen and the founders are very excited about kind of this GPU parallel architecture, or didn't exactly have a lot of applications. They made a graphics card with a lot of demand in the video gaming industry. So a lot of gamers were buying NVIDIA cards for the past 20 odd years. And then something in 2012 happened, what a bunch of researchers in, I think, Montreal accelerated AlexNet machine learning for image recognition with a GPU. And Jensen, already having an eye for he's done this a couple of times now. He's saved the company from near and almost certain failure a couple of times. And he's also, identified an opportunity correctly a couple of times. And I think about it in 2012, when he was running around the company and saying, hey, I think if we build GPUs for machine learning, the stuff like image recognition and AlexNet, it might be faster. We can actually enable AI. And, there's a few years of them giving it a go and trying to build the GPU for machine learning and delivering it to OpenAI in 2016. And then 2022, it becomes useful. So Jensen will joke like CUDA, it only was the right thing. It only took them 20 years. And you know, AI was 10 years. So with that kind of patience and insight, we keep kind of seeing what's going on. Well, with a graphics card, we can process graphics very well. And what do high fidelity simulations need a lot of processing of? Graphics. So marrying these things that keep coming up, but I really want to point out when it comes to robotics, and what might not be so clear, and I realized this 5 years ago, the future of robotics lies in the world of video games and graphics. I'm like mind blown. I've been in robotics for 20 years. 2018, it has here RTX ray tracing, which is how light bounces off of objects. You actually put the material properties on the objects to get the right. Now, this was initially designed for video games, for computer graphics, for CGI, getting sunlight to bounce off of everything correctly automatically. But when you apply the light parameters of a LiDAR or sensors to how, you know, the light behaves using ray tracing, you actually get pretty decent sensor emulation. And when I talk about sensor emulation, I just want to draw the analogy. Okay, you know, when image recognition was getting underway, you know, 5-10 years ago, and you already had 1 million cat and dog images on the internet that were labeled, you could train off of that. Well, robots, you don't have the data just online. You might need to create it synthetically, as in generate it in the simulation to use synthetic image data. And that data might not be RGB, just color camera data. That data might be point clouds. It might be different types of distortions. It might be stereo. And it's using these different types of sensor emulations in order for the robot to feed what it needs to know. So RTX is actually quite key to this story. 2020, Omniverse came along, and then obviously more generative AI and more AI tools as you see today. So I just talked about how much I'm in love with our NVIDIA RTX. It's really the key for emulating LiDARs, for doing photorealism on synthetic data sets. When you need depth and you need point cloud data, you can generate that synthetically. When I say that, is you create the environment and the objects in 3D, and that becomes the data set. And likewise, test the robot against that data set. So useful for material handling, grasp perception, grasp positions, and other types of mobile robot or you know, in-room type of perception. So why simulation? Okay, so with Omniverse, you're building up the environment. Maybe it's a worker simulation, like we have people detection, also people placement, robot simulation, or a digital twin, similar to the factory. What's the space that robot's working in? And then you can also do, you know, have also, in addition to onboard sensors on the robot, you can have sensors and cameras in the room itself. So that's where another tool called Metropolis comes in, where you can have your cameras and sensors actually in the room communicating to the robot what's going on. And that was actually kind of far along. Let's say you have a camera pointed at a loading dock, and it's easy, classified what pallets are. And I have that camera reporting back, there's 3 pallets, there's 5 pallets, there's 0 pallets. We can map this back into your fleet simulation for AMRs. And the robots then get the information it needs to know if it has a task it needs to do, or if there's some kind of buildup or emergency or spill. So Metropolis is already set up for these kind of computer vision tasks that could feed robots different types of information. Now, NVIDIA thinks of robotics as a 3-computer problem. One is training, which is the ML, the data, foundation model works. So that's kind of done on our big H100s and our DGX lines. Simulation, you actually need the RTX graphics card. So there's DGX graphics card, DGX GPUs, but also there's RTX for the graphics, for actually handling all of the visuals very quickly. So in order to train robots with simulation, you actually have a bounce back between the workloads on those 2 different types of GPUs. And then the edge, which is currently Jetson, Orin, the robot, the computer that's sitting on the robot itself to run all the pre-trained models or behaviors on the robot itself. So just in luck, we have another video.
The $45 trillion global manufacturing industry is comprised of 10 million factories operating 24/7. Enterprises are racing to become software-defined to ensure they can produce high-quality products as quickly and cost-efficiently as possible. Let's see how electronics manufacturer Pegatron uses NVIDIA AI and Omniverse to digitalize their factories. In Omniverse, they start by building a digital twin of their factory, unifying disparate 3D and CAD datasets to provide a real-time view of their complex factory data to their planners and suppliers. In the cloud-native digital twin, planners can then optimize layout virtually before deploying changes to the real factory. The digital twin is also used as a training ground and data factory for Pegatron's perception AIs. They use NVIDIA Isaac Sim, built on Omniverse, to simulate and optimize their fleet of mobile robots, which help move materials throughout the facility, as well as the pick-and-place robotic arms that assist on production lines. In the fully operational factory, Pegatron deploys automated optical inspection, or AOI points, along their production lines, which reduces cost and increases line throughput. NVIDIA Metropolis enables Pegatron to quickly develop and deploy cloud-native, highly accurate AOI workflows across their production lines. Omniverse Replicator generates synthetic datasets of PCBA defects, which are too complex and costly to capture in the real world, like scratches and missing or misaligned components. Pegatron then combines the synthetic data with NVIDIA pre-trained models, NVIDIA Tau for training, adaptation, and optimization, and NVIDIA DeepStream for real-time inference, resulting in AOI performance that is 99.8% accurate with a 4 times improvement in throughput. With software-defined factories built on NVIDIA AI and Omniverse, manufacturers can super accelerate factory bring-up and minimize change orders, continuously optimize operations, maximize production line throughput, all while reducing costs.
See kind of the story of the interplay of Omniverse and Metropolis and Isaac Sim and how it's deployed in a factory. As you see, there's a lot of robots and automation going on there.
Amazon Robotics was able to generate large photoreal synthetic data sets that improve the marker detection success rate from 88.6% to 98%. The use of synthetic data generated by Omniverse Replicator also sped up development times from months to days as we were able to iteratively test and train our models much faster than when only using real data. To enable new autonomous capabilities for the expanding fleet of Proteus robots, Amazon Robotics is working towards closing the gap from simulation to reality, building large-scale multi-sensor, multi-robot simulations. With Omniverse, Amazon Robotics will optimize operations with full-fidelity warehouse digital twins. Whether we're generating synthetic data or developing new levels of autonomy, Isaac Sim on Omniverse helps the Amazon Robotics team save time and money as we deploy Proteus across our facilities.
That video jumped right in a little bit. We have some warm-up. But I'm showing videos of these large installs, but in fact, Isaac Sim is free to download as long as your computer has a GPU that can handle it. You can go on GitHub and download all of these things. And again, it goes to the premise, if you have the environment, can the robot program itself? But here Amazon was using Isaac Sim for synthetic data generation, basically to train and how to get the robot to classify things, like the robot's understanding the space that it's working in and all this other stuff. And on the manipulation side, understanding the pose estimation, object detection of when it needs to pick up a box, and how to move things around. So this is the video. Oh, okay. So robots are not going to move forward without functional safety, not to much extent. AMRs have a functional safety methodology that's pretty well understood. That's why those have been entered industry a little bit better. But one of the reasons why you don't really see these robots in the home, or you're not really seeing humanoid robots yet, is these machines have mass and they will cause damage. When I was working on the Roomba in 2006, to get our CE mark, we had to document I was one of the interns documenting a full qualification program for a 5-pound robot promising within a very small percentage of risk that it will not fall down the stairs. And so my thinking on robots that are larger is in order for insurance to accept it, in order for regulatory bodies to accept it, you need to be able to build test cases and scenarios where they will be safe, whether it's, you know, not even a matter of attacking, but just failing or falling on something or falling downstairs. So these are very real scenarios. Here in the factory, people want to put more robots and more stuff in a smaller space. Right now, things are perfectly safety caged, which takes up a lot of space. So really like to remove those cages. And so one thing that's happening is the industrial safety standards are a little more aggressive than the self-driving car safety standards right now. A self-driving car can classify that a person is in front of it and stop, and they call that safe with a computer vision, with an AI-enabled computer vision system. Well, industrial safety still mandates kind of the older, more expensive switches, brake beams from lasers, that kind of thing. So NVIDIA, we have a program called IGX, which is building the electronics to support functionally safe person detection. So we think of safety of three different things. Reactive safety, which is, you know, don't hit it or it's about to hit it, kind of like a force sensor. Proactive sensing, which is like, you know, I know these two AMRs are on the same path. We can, because of the fleet management, I can prevent it even before they see each other. And then like predictive safety, anticipate the future exposure based on past performance data. So how does it fail? Has it failed in the past? How do you improve that? And a lot of that is actually feeding data back into your model for retraining. And self-driving cars, I keep going back to that analogy because it's a little more to get your head wrapped around. If a car were to experience an incident on a test drive, it would take all that data before and during whatever happened in that scenario. They would use that data to create more scenarios and then retrain the model. So that's what robotics, all types of robots would be doing, is when they do encounter a scenario they don't expect, use that data, like, oh, I didn't know that a metal broom, which is reflective, and so cameras and sensors don't really see it, lying on the floor is going to trip this up. And then you got to retrain everything and make sure it has that metal broom scenario in there. Because it's just unexpected things are going to happen, which is why humanoids or other more sophisticated robots are definitely going to slowly move from industrial, because industrial, you can at least constrain the environment a little bit more. So here's an example of how it would work. A camera is looking at a scene and watching how close in proximity the people are to the robots and be able to tell the robots to stop when a human gets too close. But doing this with a camera instead of how it's done currently with other types of sensors.
The projection on the screen is just lagging.
Yeah. Oh, man. So I can't go fast at all. All right. Let's see.
There we go.
All right. So that's how it would look. Let's go next one. And actually, now I get to the contents. Okay, I'll move a little more quickly. Well, we're talking about all these different things. So synthetic data generation is just a need. Scaling edge AI. But where it's starting to get really interesting is reinforcement learning, AI for robot and grasping, and visual SLAM. Oh man, it's not even moving to that one.
No, went forward and then went back. I'm gonna blame Google.
Blame Zoom. Blame Chrome.
Gotta blame somebody.
Always
well,
blame
that's
Chrome. Always blame Chrome.
I'm actually going to skip through synthetic data generation and kind of just get to more videos, because I think just videos are more fun. Okay, let's see. Because this was kind of explained in the factory video, but it's about, you know, AOI is automated optical inspection of different parts. So let me just get to this video here.
So I think your trick of turning the computer on is good.
Yeah, I'll do that.
Chromecast is just going.
To achieve this, they're building digital twins to simulate their packaging and distribution centers using NVIDIA Omniverse and Metropolis. This allows them to test variations in layout and optimize workflows to accelerate throughput before making any physical investments. As new products and processes are introduced, Omniverse Replicator and NVIDIA Tau can be used to create photorealistic synthetic data to retrain the real-time AI models. These updated models and optimizations are then transferred to the physical world. From here, NVIDIA Metropolis applications monitor and adjust conveyor belt speed in real time using AI-enabled computer vision, helping prevent congestion and downtime across miles of conveyor belts.
That's an example of using combination synthetic data. Not exactly a robot, but conveyors still doing a lot of important industrial work. Move forward a little bit. But let's talk about the fun stuff. Let's jump to reinforcement learning. Okay, so I think everyone's seen these types of projects. 2016, Google actually did this in the real. They had a thing called an arm farm where they had, I don't know, like 20, 30, there was a blog about it. Many arms picking up and dropping objects and trying to learn from it. Well, having physical arms in real space in normal time is really slow. Well, what if we can speed up time? So this is a release of Isaac Jim, and using the shadow hand to then train the policies through RL. And here it says, yeah, 42 years of robot experience simulated in 1 day. And this was 4 years ago. And one of the things to think about when it comes to robotics, especially when it comes to these AI gyms or reinforcement learning environments, is compute is only exponentially compounding. Granted, I know I might have been a little bit of a laggard 5 years ago, but realizing there was these key blockers in robotics. So once I realized how much compute is growing, that is really what's unlocking all of these things. And it's going to be a mind-boggling amount of compute online in less than 5 years. So you just throw some GPUs at this and you can solve some really big problems. So RL is currently used mostly, we have news, robot dogs walking policy, humanoid walking policies. It's entering grasping, like NVIDIA Robotics uses their own version of RL transfer learning and their own version of a gym. And here's an example. I really care about unlocking robotic assembly and manufacturing. They'll actually be able to onshore and put manufacturing where it needs to be. And so here's an example of policies being trained in Isaac Jim for a board of different types of manufacturing and assembly tasks. And here's an example of all the different types of manipulation, some of the, like a nice montage of all this different manipulation work that's been happening over the past few years. So when you throw an obstacle in the way, can it do its own trajectory planning? Like here, the stick is in the way. Here's grasp positions on the mug, thousands of times over. Can it figure out where to put the object in space? Can it move this thing around? This is a teleop application because sometimes teleop is used as the training data in addition to video data and reinforcement learning. So usually it's reinforcement learning, transfer learning, and imitation learning. Transfer learning comes from teleop, and we're trying to move more of this learning to come from video, which gets really interesting because there's a lot of video out there. So this is where we map it to our humanoid robots, because if you have video of people moving around, can the humanoid learn from that about how to move around? And this is where we're getting to when you can translate what's happening into the sim, then use the sim as the training data to train and test the robot. You have this flywheel and this loop going on. Let's see. So yeah, high enforcement, and we had a new release. There's a new release of Isaac Sim 4.0 out that came out in early July if you want to fiddle with it. And Isaac Lab is the new version of Isaac Jim. Isaac Jim was depreciated. Isaac Lab is available on this current Isaac Sim release. If your GPU on your robot on your home computer can handle it, you can download it and start playing with it right now. So Isaac Manipulator, these are available to download, but it's generally steered more towards industrial robot arms that want to embed a Jetson or Orin in its controller. But these packages are available. Image classification, and then foundation pose, where we output the 6D pose of the object that it's looking at, which is very essential for grasping. Foundation grasp, basically moving towards foundation models for grasping, where you train a model or a certain behavior, you add a little more of your color to it, whatever that might be for your task, and it can work. That being said, the things I'm seeing getting traction is foundation pose, because it's kind of very necessary, but also very ubiquitous across a lot of different applications. And then Motion, which is the trajectory planning given obstacles in the way of the different robot arms. And here it's being used in a manufacturing task and a pick and place. I'm hoping the fun video comes up soon. Okay, vSlam, AMRs. We also offer some packages online for SLAM. That's been coming online, and we have a philosophy that we're working with. It's trying to basically do it a camera only or stereo camera only, no LiDAR. But we're really more on the side of the scene reconstruction as well, and trying to make it easier to build up these 3D environments that AMRs or different type of mobile platforms are going to be working with. So I do have a video on that.
With Isaac Sim, we generate massive amounts of synthetic data for training and validate the perception stack inside physically accurate simulations, narrowing the sim-to-real gap. Isaac Perceptor infrastructure will enable us to train a navigation foundation model that can perceive its environment, predict the future state, and determine the optimal action.
So that's a little bit about Isaac Perceptor and this little robot here.
Erin, we have a question online. Dillo?
Sure.
Yeah, hi. You mentioned, if your home server can handle this kind of load, or if you have a sufficient graphics card. I was wondering if you had a recommendation for like a baseline GPU, if you were going to be buying or building a server, and if you had like a baseline recommendation for what NVIDIA GPU we should get for that.
Can we take that question at the end of the meeting, Dillo?
Sure.
All right, thank you. Sorry.
And I will say, I don't have that off the top of my head, but if you look up Isaac Sim documentation, it's all there. I think it's on the first page, like setup and record.
All right, thank you.
No problem, thank you.
With Isaac Sim.
So I went through all of these different topics, and it's updating. So synthetic data generation, scaling edge for AI, scaling edge AI, reinforcement learning, AI for robot grasping, and vSlam. I think this is the fun video.
This is NVIDIA Project Groot. A general purpose foundation model for humanoid robot learning. The Groot model takes multimodal instructions and past interactions as input and produces the next action for the robot to execute. We developed Isaac Lab, a robot learning application to train Groot on Omniverse Isaac Sim. And we scale out with Osmo, a new compute orchestration service that coordinates workflows across DGX systems for training and OVX systems for simulation. With these tools, we can train Groot in physically based simulation and transfer zero shot to the real world. The Groot model will enable a robot to learn from a handful of human demonstrations, so it can help with everyday tasks and emulate human movement just by observing us. This is made possible with NVIDIA's technologies that can understand humans from videos, train models in simulation, and ultimately deploy them directly to physical robots. Connecting Groot to a large language model even allows it to generate motions by following natural language instructions.
Hi, GL1. Can you give me a high five?
Sure thing. Let's high five.
Can you give us some cool moves?
Sure. Check this out.
All this incredible intelligence is powered by the new Jetson Thor robotics chips, designed for Groot, built for the future. With Isaac Lab, Osmo, and Groot, we're providing the building blocks for the next generation of AI-powered robotics.
That was our announcement in March that we're combining all of these technologies to build foundation models for humanoids. That being said, because it's embodied AI, the embodiment is whatever you want it to be. The idea is if you have, the URDF file of the robot, you have different decent, physics modeling of the actuators or whatever you want in that file. It doesn't matter what the robot is. What matters is you can train it against the environments and the objects that you wanted to implement. And this is all done in simulation. Actually, funny thing about that last scene, a bunch of us on the team was like, is that fake? And like, no, that's a real shot. I'm like, but it looks fake. It's so good. And so now even I'm like starting to question like, oh, what's a simulation and what's real? At least when I look at videos. But that's what's really exciting about all of this is, oh, there's a little more, because here's how the flywheel actually gets going. But anyway, to conclude the thought, all of this was adding up to this embodied or physical AI. And as I mentioned, I think a few more times, if you look up Isaac Sim, if you look up Isaac Lab, you can download them off of Git. The documentation's online. We're not holding back. And actually Isaac Lab, I think, is the open source as well. Like you want people, the whole research community to contribute to it. So we're not holding back and making this accessible. And the system parameters, that's in the documentation as well. But the flywheel here for generative AI is, this requires a lot of 3D assets, right? And who makes those? Well, AI makes those. So let's talk about that here.
Planning industrial spaces, like factories or warehouses, is a long, complex process. Let's see how you can use NVIDIA Omniverse and generative AI to connect your OpenUSD to fast-track planning concepts, like a storage extension to an existing factory. Use SyncTwin's Omniverse extension to quickly convert a 2D CAD floor plan into a 3D OpenUSD model. And populate it with SIM-ready OpenUSD assets using Omniverse's AI-enabled Deep Search. Then use prompts to generate physically accurate lighting options with Blender GPT. Realistic floor materials with Adobe Firefly. And an HDRI Skydome with Blockade Labs. To see the new space in context, compose it on a CZM geospatial plane next to your existing factory digital twin. Then, to share with stakeholders, use one click to publish the proposal to Omniverse Cloud GDN, which serves a fully interactive review experience to any device. Fast-track your factory planning process with NVIDIA Omniverse and generative AI.
So now Gen AI can be used to create the 3D assets or extrapolate the 3D rooms, whether you're scanning them or extrapolating them from your 2D CAD building software suites. And, it's just, I joined NVIDIA 2 years ago, kind of realizing that this would need to be the way things go in robotics in order for some things to start working. Well, I've been in robotics about 20 years. And I was selling LiDAR in 2019 and 2020, which was 2 years worth of talking about 3D perception pipelines with different robotics companies. And that's when I realized that no one really had an application. I didn't even call it a simulation at the time. I was like, nobody has an application environment to relate for complex 3D perception tasks. Self-driving cars were making their own sims, but all the smaller robot companies didn't have the resources. Some were starting to make their own versions, and that has happened. And some standalone robotics startups do have their kind of own internal simulation tool that's working for them, like Ambi does and a few others. But it's just connecting all these dots. And then I realized in 2021, I'm like, man, all these robot companies, like simulation needs to get better. And I was working for a company, we were consulting, I was consulting at the time, and trying to sell projects in Unity, but actually learned how Unity actually has some architectural issues when it comes to being a robot simulator. Same thing with Unreal. Those engines were created for consumer visual experience with games. So there's ways that things just weren't talking to each other. It's not quite the right tool for that job. And then NVIDIA was creating Omniverse, and they were designing their drive sim at the same time they were architecting Omniverse. So those two were kind of done in parallel. And Isaac Sim was a natural outpouring of that as well. Outpouring of that. So I think that's what I have for today. I can take questions now.
Yeah. So if we have questions, if you wouldn't mind walking up to the phone so that
Sure. The applause is mostly for all the video editors.
No, thank you for the good presentation.
Yeah.
I want to go back, just touch on the reinforcement learning simulation. It seems like when you're working on reinforcement learning for grasping simulation or also for bipedal gait development, a key element is going to be the friction model and the physics engine. And nobody's as perfect. And that's, when you're talking about, Unreal and some of those game developer ones, I mean, they've taken some shortcuts, especially around friction, in order to make the friction model or the physics engine tractable. So my real question is, can you comment on the limitation of friction model in the simulation?
So I can't comment on specifically friction, but what I will say is different needs require different simulators. And for robot grasping, the people are still enjoying the physics simulation of Mujoko and Drake quite a bit, like those other ones. But something that actually relates to friction is collision meshes. So, and I was browsing YouTube, and you look up two-minute papers, Isaac Sim, or 2-minute papers, RL, NVIDIA. There's been some recent developments in how to handle the contact points in the collision mesh. When I say collision mesh, is in just CGI or video games, those assets don't need to know that one ends and one begins. They don't hit each other. They just kind of mush and merge, and you make it look right. But in these robot sims, you actually need to define that there's a mesh around the object that's like either a pure collision or deformable, or maybe when two objects slide on each other, there's that friction or this behavior. All of that is very complicated to get perfectly right. So, so when companies come to us and say, we want to understand the traction of our tractor tire wheel in mud and simulation, we say no. or we say, you know what, that sounds like an interesting problem for your team to solve. Maybe somehow measure a data set and then interpret like the variety or your own statistics and behavior on that. That's hard to do right now. But where it's going is, mass and acceleration of objects, or mass and acceleration of the gait, or how, the walking policy, like what is it moving? How can it accelerate? And also starting to get more requests around actuator behavior, like when it accelerates and decelerates. So there's a lot more that, when it comes to physics integration, there's a lot more that all these tools need to go. And right now, doing what you can with just understanding contact objects without not much additional friction and physics is probably the best way to start. A lot of people, not to say that, a lot of people want to jump to the most complicated problem, and we're like, we're not there yet. But there's a lot we're starting to unblock that hasn't even quite been dealt with yet, which can open up new possibilities for today.
How does
Oh, we can do internet, or me first. Someone on the internet has a
go ahead, Tony.
Me? Okay, so as the club's obnoxious AI and humanoid skeptic, so my question is, you talk a lot about foundation models. When you talk about a foundation model, are you referring to an end-to-end learning trained model, like, a multimodal AI, or are you referring to something more built on top of that? Like that plus other things, or yeah.
It'll be that plus other things, and probably even the foundation model will be kind of, it's going to start being more siloed. like everything's gonna have a starting point.
Okay.
But there's the vision of if you're doing a humanoid, you need to add on your specific configuration, maybe add on some of your specifics around your task, but
Sure. Okay,
it's
but
still
are you
enough there.
Are you envisioning that just being one giant neural network, or are you envisioning a more complicated system than just one giant neural network?
Do not know.
Okay, so
I think we'll do whatever starts working.
Okay, yeah, I predict the giant neural network approach will not work. My other question is, this is just a general question, is my experience with this is it's really hard to hit the 90% barrier on learning-based systems. The best papers I've ever seen was 4 to 5 nines of reliability. Do you know of anyone who's getting above that with a learning-based system? Or is that just a hard limit?
All of this is practically very early.
Sure.
Like even the words reliability in a research paper just rings ironic to me.
No, well, it's still reasonable to say, oh, we did this 100,000 times and it worked 100,000 times. If you can't get 100,000 times in a research paper, I mean, real world's probably not.
That's fair. The research paper comes first. I think what I'm thinking of is, was that research paper about a humanoid or?
There have been a number of papers about, say, ImageNet deep learning success rates, just all these success rates in the paper of like, okay, we're gonna have a robot, we're gonna have it do something 100,000 times.
Yeah.
Is it going to succeed? And the answer with classical technology is, oh, well, hundreds of million times if you push it hard enough.
Did the robot actually perform that task, or was it synthesized?
During both physical and simulated tasks. So yeah. I've just never seen anyone pass that barrier. And I'm curious if anyone's ever at all succeeded at passing that barrier, or if that's a fundamental limit.
For an AI robot?
For a deep net-based system. So a CompNet-based system, an AI-based system. I know it depends on your definition of AI. Classical planning, if you count that as AI, that can pass, that can be 100%.
Yeah, like classical planning for repetitive, and this is what I explain to manufacturers. Classical planning for repetitive tasks can be 5 nines, obviously, because that's the point. Like a welding robot is,
that's not right.
AI is statistical. AI is probabilistic. It's not going to do the same thing 5 nines just by the way that it's approached. Now, if depends on the generalizability of the task, but what's actually happening today is like there's not many AI-based systems out there to test, and people are trying to get robots to do things with classical approaches, which is not
works really well when you do it right.
Yeah, it's something that the industrials need to understand. If you're making a robot to handle a higher variety of tasks and objects, the variety it can handle successfully will also not work in its favor when it comes to reliability.
Sure.
You're kind of asking, I want you to do all this random stuff perfectly. And it just won't. And now you're hearing my rants. But
no, this is good.
If you set up a perfectly repeatable task, you can expect that a robot will behave in an acceptable, repeatable way. If you set up a robot in a chaotic environment with different objects, with different obstacles, with different happenings, it's going to get tripped up at some point, and that's kind of like, that goes hand in hand with what you're asking the robot to do, is that it will fail at some point. Now, the question is, how do you control the failure and make sure it's not catastrophic?
Also, it starts to become complicated. What's your definition of failure?
And that's where, like, and trying to get your head wrapped around all of it, like, I like to draw the analogy, robots are probably not going to be better than how a mammal behaves. Like, it's gonna do some acceptable things and do some unacceptable things. And the only place you can apply a definition to that is if you're putting a product in a certain place to do a certain thing. But once humans expect robots to be perfectly good at everything, we don't expect humans to be perfectly good at everything.
Yeah, robots get treated differently than humans, so they have to be perfectly good at everything, I think.
Also, I think that generally the population,
or perfectly good at everything they're sold at.
I think generally the population misunderstands how complicated the real world is. So while perhaps we can get humanoids and these different types of robot embodiments to start doing a slightly higher variable task in a controlled setting. When I was an intern on Roomba, and we're just we thought a floor was easy. A floor is not easy. There's so many different things going on the floor, and the way the people beat up those Roombas in their house, like there's like thousands and thousands of different failure points, and we're just talking about a 2D scenario here.
Yeah.
So the complexities
We
expand.
learned that the hard way in the club as well.
Tony, you
Yeah.
should,
Yeah.
you should let
Yes,
some others.
I will let someone, thank you for answering my
Yeah.
question. I have no for hours.
I can tell. All right. Oh, I have a lot more questions. Okay.
Camp, you want to go next or pick somebody else?
Sonali's next online. Go ahead, Sonali.
Hi, thank you for the great presentation, Erin. My question is, which NVIDIA platform would you recommend for synthetic data generation for something like object detection? And could you give us a sense for how good the performance is compared to real data?
So I think you can find all of that online. I'm not having it on the top of my head. And the performance against sometimes a mix of synthetic data and real data is actually working for the model. So if you can get it depends on which one's cheaper or which one's good enough. But synthetic data, especially for people detection and a bunch of other things, has been working quite well. So there's a bunch of blog posts about Omniverse replicator synthetic data generation on Isaac Sim. Regarding running it on the edge, the Metropolis pages has information on which Jetson you might want to use for which application.
Okay, thank you so much.
Thanks.
How does Omniverse compare to Gazebo?
Good. Well, I know there's a good example. Intrinsic, who leverages Gazebo a lot, announced that they're using Omniverse and Isaac Sim with Isaac Manipulator and putting Isaac Manipulator.
Who does that?
AI
Who's using it?
Intrinsic.
Oh, Intrinsic. Yes, they did some stuff with Google, right? That is
Gazebo. And this is the main thing. Like once I got this in my head a few years ago, that the simulation is the training data. The simulation is training the sensors. Gazebo doesn't have that kind of fidelity.
So you're saying that Intrinsic was using Omniverse in lieu of Gazebo?
Yeah, Intrinsic is primarily using Gazebo, and to extend their product line in order to have AI generated manipulation trajectories, they announced that they're using Isaac Manipulator, which is based on Omniverse.
Interesting. Thank you.
So Omniverse can actually have the accelerated reinforcement learning, can actually serve as the training data for the perception pipelines, and Gazebo doesn't have that kind of fidelity.
Thank you. Heba, I believe you're next.
Yes, thank you. First of all, I just wanted to say thank you so much for presenting and sharing. It was super insightful, so thank you. My question was that given your extensive experience in robotics and industrial automation, what do you personally see as the most significant challenges and opportunities for AI and robotics over the next few years, aside from what you've mentioned, and particularly with the advancements from NVIDIA's intelligent video analytics platform?
This is a fun question because I've seen the past 20 years.
Yeah.
Things get stuck. Kind of realized 5 years ago, robot performance is stuck until simulation gets its act together in order to be able to get deployed faster. But I still, when you look at the statistics in the ABI reports, not many robots are being sold. And so there's a more practical question that the customers, the end users of robots, don't really know how to buy them. They don't know what to expect, and so the startups get stalemated around either unreasonable expectations from the buyers, or the buyers aren't clear with their requirements, or they just don't understand they might need to change their operations a little bit in order to have the robot be successful, or they can't even evaluate between vendors. it even gets worse. A lot of the end buyers don't even know how to update their IT system to integrate more complex automation. So while the robot itself is going to get smarter and hopefully solve some of its own implementation problems, there's implementation technology hurdles that the end consumers and purchasers of these systems would have to figure out if they want to adopt. And I really think a lot of these businesses are going to hit a turning point soon where they're going to have to figure it out or go out of business. And I think there's, with, you know, the mass retirements, meaning a lot of traditional industries are actually going away with their owner retiring, and the economics of it, there's actually PE funds going around snapping up manufacturing businesses in order to automate it. So there's a huge opportunity for people to make money if they're on the end business side of the fence. Adding automation to existing businesses in order to make that more profitable, I think is going to be easier in the next 10 or 20 years than having a robot company. But that being said, I think in 5 years from now, the way compute's getting online, the way AI simulation is getting going, we're going to see robots that can do a lot of cool stuff, but it's still going to take that end consumer to figure out how to integrate that robot that's very capable into their workflow. So that's kind of how I see it going.
All right. Thank you so much.
Next.
Daniel, you're next.
Hi. Hey, about 5 years ago, I tried to get people to do a little subgroup within the homebrew organization on the Jetson boards. And the biggest problem that we had was there's virtually no real information for programmers and homebrew people to get started with the Jetson boards. It's great if you want to pay DLI $500 and you want to take their courses. But the only person that actually put out some courses was Paul McWhorter, who's not with NVIDIA. But those are the style courses. If you want people like us to adopt your products, you need to kind of give us some information. If you Google Isaac Jim or anything like that, you get 3-year-old videos. You download the containers and they don't run on your board. I mean, it's very frustrating. And I'm you know, I want everyone to adopt Jetson boards, but the learning curve is huge and there's just not enough info. Is there something you can do on your end to put something in somebody's ear to say, we need to try to get a hold of the hobbyist and introduce our products to them where they don't have to pay $500 to DLI to learn how to use our products? Because they're not large corporations like Amazon. We're just homebrew people. You understand my question? Thank you.
Oh, and I've heard it before. Actually, there's another guy on our team, Dusty Franklin. If you find him on LinkedIn, he has this rant every week. And I think we're a little bit better than we were 5 years ago on having things online. That being said, tutorials on YouTube are slower to come out than the documentation. So the documentation comes out with the releases; those are online. But the YouTube videos are going to be older. So also Jetson and Orin is positioning, well, it was positioned a little more on the lower cost end 4 or 5 years ago. As I mentioned in that video, Thor is gonna cost a lot more than a few $100s. And we are moving more towards this industrial scale where these robot companies are saying, I need a hell of a lot more compute to run all these models and computer vision algorithms and all of that. They just want more and more and more and more compute. So unfortunately, moving in the future, the AGX line is going to become more expensive and industrial, and those companies are willing to pay for that level of compute. Which I say it's unfortunate for the hobbyist group. But that's kind of where our focus is.
Were you saying that doesn't even publish something?
Yeah, he posts a lot on LinkedIn, and we have a group of we call them like technical marketing engineers who generally put out this content. Franklin, Dustin Franklin. But he likes keeping the homebrew community alive and well, and he's very, very passionate about it. You see him? You find him? Yeah. So there might be a bunch of stuff that he's posting.
Dillo, go ahead. Hello,
Okay,
Dylan.
my turn. Okay. Hi. Oh wow, I have just like so many questions. One, I will follow up with the last one and say, when you hear hobbyist, also think startup. Also think companies that are just getting started and trying to put, maybe they don't have $50 million in funding. And they're just trying to put together their system, or do we go ahead and throw some money at time and effort at bringing up, like Isaac sounds great. I can think of a couple companies I'm consulting for right now where that would save them from having to actually go out and build a whole prototype or a series of prototypes so we can run it through that. So that would be one point. Another is speaking to some of the pain points that were covered a few minutes ago. Also, can we get the I guess I would say the OS and the NVIDIA side of the house to talk to the application side, because I see updates for like Omniverse or for drivers, for Jetpack and things like that, and immediately it comes out. You can't get the old version if something goes wrong. All the documentation changes, but this is what you're supposed to use, and so you go and update. And yeah, the NVIDIA demos work, but OpenCV hasn't been updated yet. NumPy, PyTorch, all those, they just break. And so now I have to try and backgrade, but I can't get the backgraded package because it's off the website now, because we're supposed to use the new thing. And I've gone kind of like 9 rounds on the forums with the support people there, and they're like, "Oh, we'll just use the new, the new version. Sorry, the old one isn't available." I mean, yeah, but now I can't because it's, there's the whole thing that makes NVIDIA attractive, the whole thing that makes it attractive and useful versus just going off and getting Gazebo is you can use like the full stack of, the latest GPU, the latest, CUDA hardware, that is accessible through CUDA, within, and I can use it with what I'm used to using, which is, NumPy, OpenCV, PyTorch, things like that, things that, the AI and machine learning community, kind of run on. And I have this brand new fancy board and I can't get my tools to work. So that's a rant.
The time's up, Willow.
I've observed. I'll say this to your rant. Valid. Observed that much, and what I can say is, we're kind of building New York City while we're living in it.
Yeah.
And there are more than thousands, like millions of people who want millions of different things for their custom projects. And what happened this year with, the Groot announcement and the push at GTC is we can't satisfy every ask. We're just not
I get that.
a large team. We really try to enable our ecosystem. So NVIDIA provides, our objective is to provide core technologies that, being a business, require GPUs. And we really hope these GPU-enabled technologies really unlock value for you. But then we want to provide that to ecosystem providers who then provide the rest of the value, and whether or not they're going to the end customer. So we're not, our goal is not to become a warehouse automation supplier. We're not going to be a humanoid builder. We're not going to be an industrial arm manufacturer. We're not going to do that. But when these, or we're not going to be a sensor provider. So we want all the cameras and sensor companies to, you know, if there's key value in what NVIDIA is offering to your project, we're here to enable the ecosystem to take that technology, but then do their respective value add.
Right.
So,
Right.
some documentation for some stuff is not going to make sense. And honestly, some things we're just actually not prioritizing internally because we're really going after this big embodied AI vision.
Yeah. Okay. So one final thing is what do you see as sort of like the we talked about, like, you know, Isaac Sim previous and compared it to Gazebo and also Unity. I actually kind of noticed this about 6 or 7 years ago when I was working at a reinforcement learning company, and we were working with robotics. We started to see a lot of the old classic simulation software stacks trying to get into, you know, I guess games, and the games guys realizing that, hey, they're kind of like their margins, like, or, you know, the well is kind of dry. So everybody's kind of racing for robotics.
Be brief.
Yeah. So really quick, what do you see as sort of like the horizon for utility for, say, something like Mujiko or Gazebo versus Isaac Sim? Obviously, if you're like a Unilever or Pepsi or Ford, and you do need to simulate a, you know, 50,000 person factory with, you know, 10,000, you know, that's great.
Hello,
even if you're a smaller factory,
be brief.
Yeah, even if you're a smaller factory or you're a small manufacturing, you know, where is that? Where do you see that makes sense? Because all the demos are Boeing. So all the demos I see are like Boeing sized factories. Like if we want to bring up a whole new line, you know, and
so let me answer the questions, and I think I'll move on to the next person. But our stance is use the best simulator for the job. So for some robot grasping tasks, people are finding success with Majoku and Drake because they have slightly more refined physics engine integration. They're still using GPUs to accelerate it. That's what we're aiming to do, and integrate between all these different simulations using USD. So that's where you use the best simulator for the job. When it comes to factory digital twin, unless you're automating the factory, it doesn't make sense. Like if you're just trying to do design and build and layouts, there's a lot of other tools for that actually. And what I've observed is unless you're really putting a lot of interactive automation in there, that automation, and perhaps if the layout's changing a lot, then that's where having a more fully featured digital twin environment helps.
I was thinking more like for data generation, like for, you know, like.
All right. Dillo, hang on. One last question. NJ, go ahead and ask your question. NJ, ask your question. Unmute, please.
NJ put something in the chat and he said he's having trouble with audio.
Let me look. It was, I'm pulling up the chat.
Pulling up the chat's perfect.
How does one connect to that 2D print to 3D and add humans and other equipment? Can you repeat which version of Omniverse is the one I should explore? All of this is online in the documentation. I think if you start these search terms, Omniverse download and CAD 3D. So let me, just look up, like, I mean, in the offline after I could like send the exact links, but like Omniverse, download, CAD 2 3D. Do I have any job openings? They're all online. Let's see. PeopleNet or a person. I forget the name. We have a model. We already have a pre-trained model for recognizing people. Or people. Look that up.
You can list all the videos.
Yeah, I have that in a LinkedIn post. So if you pull up my LinkedIn, I actually have an article saying all my YouTube videos from Automate. Because a lot of people were asking me about it. So you could share. Have you found it yet?
Erin,
it might take a little more.
I want to thank you for giving a great presentation. If we could all give Erin a big round of applause. Big Homebrew Robotics round of applause. Thank you very much for your
thank you.
energy to this business, and really looking forward to the future and the great things you and we're going to do. So thank you very much. All right, guys, this concludes our HPRC general meeting for July 31st, 2024. We'll go into random access now. And thank you very much. Thank you again, Erin.
Yay!
Keep up the
All right,
good
I'm
work.
gonna stop the video.
Stop the video.